Hello my dear student, let's complete Unit 2 Force in Motion. Today we will study Lesson 3 Motion. What is the meaning of motion? Motion is a change in position of an object over time relative to a reference point. Motion happens all around us. Every day we see objects such as cars and motorbikes move in different directions. In this lesson we will study motion, relative motion concept, and types of motion. First, when the object position changes as time passes according to the position of another object, we can say that the object is in a state of motion. So, what is the speed? It's the distance covered by an object in a unit time. The measuring unit of speed is meter per second. So, when we need to know the speed of an object, of a moving object, we should have distance and time. The measuring unit of distance is meter and the time is second, so the measuring unit of speed is meter per second. What is meant by the speed of an object is 20 meters per second? This means that object covers distance of 20 meters in 1 second. Second, relative motion concept. Relative motion, what is this? It is change in the object position or direction as time passes relative to another object or a fixed point known as frame of reference. Relative motion, it is the change of an object position. It is a definition of motion, but relative to another object or fixed point. What is the frame of reference or reference point? This fixed point used to determine the object position or to describe its movement. What is the reference point? It's a fixed point used to determine object position or describe its movement. To know the meaning of relative motion, let us study the following applications. Application number 1. There are two cars, have the same speed and direction, the same type, and have the same speed and direction. Okay. What is the observation? As in the figure, you will imagine that the two cars stop moving and no motion will be observed. But when the two cars have the same speed and direction as these cars, you will imagine that the two cars stop moving and no motion will be observed. This is according to the reference point. Okay, this is an observation. Number 2, application number 2, if your car moves beside a stopping car, your car, the red car, is moving beside a stopping car, which is the yellow car. If your car moves at higher speed and in the same direction of another car. So in this case, if they are moving in the same direction, but your car is higher speed, what is the observation? You will imagine that the other car go backward. But when your car is moving beside a stopping car, you will imagine that the other car are moving backwards. Application number 3, if you are in a stopping car, vice versa. If you are in a stopping car and another car moves forward beside you, your car is the red car. It's stopping car and another car moves beside you. What is the observation? You will imagine that your car moves backward because the yellow car moving forward, you will observe that it moves backward. Application number 4, if your car moves in an opposite direction to another car moves at low speed, you will imagine that the other car moves at high speed. So, if they are opposite to each other, you will imagine that the other car moves at high speed. With this, we know the meaning of relative motion, which is the change in an object position or direction, but relative to another object or fixed point. Types of motion. The motion of objects is divided into two types: transitional motion, number 2, periodic motion. What is a transitional motion? It is a motion in which the object position is changed relative to a fixed point from time to time between initial and final positions. Example: a person's motion, bicycle motion, train or car motion. Number 2, periodic motion. It is a motion which is regularly repeated at equal periods of time, as vibrating motion as the pendulum. Number 2, circular motion is the movement of moon around earth. Number 3, wave motion is the water waves. Wave motion, we will study wave motion, which are two types: mechanical waves and electromagnetic waves. Number 1, mechanical waves. They are waves that need a medium to transfer through. Their characteristics: they are produced due to the vibration of the medium particles. Number 2, they don't travel through free space. We need a medium. Their speed is relatively low. Examples: sound waves and water waves. Number 2, electromagnetic waves. They are waves accompanied by electromagnetic force, and they don't need medium to travel through. Vice versa, mechanical waves. Their characteristics: accompanied by electromagnetic force, can spread in all media and free space, and their speed is relatively high. Examples: light waves, microwaves, radio waves, X-ray, gamma rays, ultraviolet and infrared rays. Give reason: we receive the sunlight and we don't hear the sound of solar explosion. This give reason is very important because the sunlight is electromagnetic wave which can travel through space, while the sound of solar explosion, boom, is mechanical waves which need a medium to transfer through and can't transfer through the space. Number 2, give reason: we see lightning before hearing thunder, although they occur at the same time. Lightning is light, so it's electromagnetic wave, but sound is mechanical waves, which is speed low, but electromagnetic waves is high speed. Technological applications of waves. Some technological applications of some sound mechanical waves. Number 1, examining and curing equipment for the human body using sound waves, which is ultrasonic waves. Number 2, musical instrument. Number 1, stringed musical instruments such as the violin, the lute, and the guitar. Number 2, pneumatic musical instruments such as the flute and reed pipe as in the figure. Number 3, amplifiers and devices of distributing and controlling sound used in broadcasting studios. Some technological applications of electromagnetic waves. Number 1, ultraviolet rays. They are used to sterilize the sets of surgical operations room. Number 2, X-rays. They are used in photographing bones to detect the sites of bone fractures. Number 2, examining metal rods in the industry and showing errors boards. Number 3, cracks in these minerals. Number 4, studying the inner structure of mineral crystals. Number 3, gamma rays. They are used in medical purposes as a treatment and covering swelling and tumors. Visible light. Number 4, they are used to photographic camera, television camera, light shows. Infrared rays. They are used in night vision system. Number 2, remote sensing instrument to photographing the earth surface using satellite. Number 3, cooking food. Why? Give reason: because these rays have heat effect property. Give reason: infrared rays are used in cooking food because these rays have heat effect property. And thus we have finished this lesson. Thank you for listening. Regards, Miss Sarah.